Hi, and welcome to this new chapter where we will look into the in-order tree traversal and we will write a program to implement it. So, in in-order tree traversal, the way we traverse is we traverse the left child first, followed by root node, then the right child. So, how we are going to implement is the algorithm we are using here is we are taking an stack, and in that stack we will initialize the current node, which is the root node, and from there, say for example this is our root node. Okay, then we will traverse to the left child of the current node. Okay, so we will move till the left is not null, and then once the left is null, so once the left of, so the left of this will be this, the left of this will be this, the left of this will be this. Once the left is null, we will pop the top item and we will print this, then we will print this root node, and then we will go to the right node. Okay, and similarly we will come up. So let me show you how we can implement this using code. Okay, so see here I have implemented it using a class named as Inorder tree traversal. Inside this I have just declared a root node, and then this is the node class where I have taken the character data type, then left node, right node, and the constructor to initialize the node, and this is my method to traverse the inorder in order fashion. So how we are doing is, let me and see, let me show you the tree first. See, this is the binary tree that we are traversing in order fashion, and in order we traverse the left child, then root, then right child. And for creating this binary tree we have followed the similar fashion as we have created in the label order tree traversal. So this is in order tree traversal class that we have created, and then I'm creating the root followed by left of the root, then right of the root, then left of the first label this B, then right of this B, followed by left of C and right of C, lastly left of D and right of D, and then at last left of E. And this will help us to create the binary tree. And then I'm simply printing in-order tree traversal, and then I'm calling the in-order traversal method, which is here. See this one. Okay, so it's very simple. So first as we should check the base condition that if root is null, then return, because there is no point of going forward because there is no node present. Otherwise we are creating a stack and named it as like stk, and then I'm creating a current node and I'm initializing the root node to this current node, and now we are traversing the tree. So for that, what we are doing here is we are checking if our current node is not equal to null, because if it is null then there is no point in traversing. So we are checking it should not be null, and then stack size should be greater than 0. Once any of these condition is satisfied, we will move to the while loop, and here we'll check the current is not null. Since the current is not null, so we will put the current node into the stack, and then we will move to the left of the current node. Afterwards we will follow this until all the left node has been covered, and once we have covered the left node, we will pop the item from the root node, and then we will print this data, and afterwards we will move to the right of this child, because you remember we traverse the left child first. So we will print all the left child, then root, and then right child. So this is what we are implementing here. We are inserting the current node, then all the left child we will push into this till this current node dot left is not equals to null, and then we will print all the node from the stack. And after we have covered all the left child and the root, then lastly we are moving to the right node. So let me run this and show you what output we are getting. So ideally the output we should get is, if this is our current node, so the follow this one, left child, root, then right child, and through this I can explain you. So we'll go to the root. So the left of this root is this. Now this behaves as the current node or the current root node. So the left of this will be this. Now this behave the current root node. So left of this will come here. Okay. So now we came, since all this, now here there is no left, so left of this is null. So we will print this one first. So we have for this subtree or sub-binary tree, we have covered the left child. Then we'll go to the root of this left child. So root is D. Afterwards we'll go to the right of this. So we will print HDI. Now this is covered. Okay. Afterwards this complete left, that is in HDI, is covered, which is the left subtree of root node B. Then we will move to B. Afterwards we will come here. So this will behave as the current root node. Then we'll come to the left of this. We'll print the left, then root. Since there is no right, then we will go here. We'll print this one, and then we'll come to the right of this. So this will behave as the current root, and then we'll come to this left. We'll print F, then C, followed by G. So let me run this, and the output that we should get is H, D, I, then B, J, E, then A, then F, C, G. So let's run this. So see here, we are getting, we started from here, we came all the way down till the left, where the left of this current node is null. So we printed this H, then a root node, then right of this, that is I. Afterwards we'll move to B, then we come to the right. So this will behave as the current root node. So we'll print J first, then E, which is shown here. J is printed first, or traverse first, followed by E. Now all this left of this root node is covered. So after all this node has been traversed, we'll go to A, and after A we'll go to the right child of, or right sub binary tree of root node A. Now here this is the current node, so we'll print or traverse F first, followed by C, then G, and the same fashion is being shown here. So this is how we can traverse in order fashion, and the time complexity in this scenario will be big O of n, where n will indicates the number of nodes. Now in the next chapter we will see how we can implement the pre-ordered tree traversal. Thank you for listening. Thank you.